Hello, good afternoon. I have no idea who we've got here, whether we're live, but hopefully this will be working. Let's have a quick look. Right. Okay, so this is a live coding session where I will be presenting probably some further work on my ARM disassembler that I've ported from GitHub. This was started last year and got lost because other things got in the way, as they do. And hopefully we'll be able to get something done. I'm not really sure where I'm up to, so we'll be sort of finding out where we're up to with that. I'm not sure. Not sure how we're going to get on with it, but we'll see anyway. Right, it's called DARM. It is someone else's a disassembler. It's for regular 32-bit ARM, and it will disassemble to usual ARM mnemonics. This is where we're up to. We're a little bit ahead of the other repository, and yeah, I've just been working on this 11 months ago apparently. So let's have a look and see where we were up to, shall we? I'm sure this will be something of a learning exercise, but we'll have a go. So I've got some issues listed on here. Is that because yes, I set up a project, didn't I? I set up a project for this so I could see what I was doing. Here we go. So we've got some use the debugger error base, not a random one. Try and differentiate the instruction types in the code. Reporting IFSR and DFSR in show regs output. Fair enough. And doing a little bit more advanced, doing ARC64. What was I working on? Operands not being very friendly and comparing against the Pyromaniac debugger output. And we've completed a number of things. So hopefully this will give me some opportunity to see what I was doing. Right, so let's go back and have a look at this. So this is the repository here. This is the source code. This is the makefile actually. And that's the makefile for the top level. All of the RISC OS things are in here. So we've got a library makefile, which is this. Interesting. And then we've got a module, which looks like it uses the same library. And then we've got some dis file. It was a tool that we created that just disassembled a single file, and then there was an example. This is just using an example of using the DARM library. So let's have a look and see where we're up to, I suppose. I'm not sure what we're going to get out of it, but let's have a look. So to begin with, let's go and build it. Build it. I've looked at some C code. Right, here we go. This is some of the C code. Actually, this was the actual. So let's build that. Use the build system, and that didn't work quite so well. Unexpected command in makefile. Alright, so let's have a see what's in the makefile. I suspect it's gone a little bit too far. I suspect it's not using the right makefile. What I'm going to do is I'm going to just symlink cd RISC OS in here. I'm going to do RISC OS ammo here. Yeah, it would not open. I have to tell it which makefile to use. Don't know how to build that thing. Okay, so let's try building that. Oh, I know what this is going to be. Well, this is going to be tedious, I think. Just give me a moment. So since I was doing this last time, I've changed how my build system works, which is now more complicated. So rather than actually building things natively on the host system, I build them in a container. And that means that things aren't going to be exported in the same way. But I believe I can make things work. I believe so, not really sure. I need to think on this. So the problem is that the library is in the library. Oh, maybe this will just work. This probably will just work. RISC OS -f makefile lib. Make the lib. Export it. Okay. And now build the module. That does work. Good. Okay, so yeah, how I've structured this is actually going to work apparently. There's still some issues I have to work out with my build environment, but this is now built. So let's make it clean. That might be a little bit easier. So delete all the files, and then we'll build the library. And then build the module. Those failed. Right, I know why those failed. That's because those files have got the wrong file name. So previously I was building natively on macOS, and macOS has a case insensitive file system, whereas now I'm building on Linux and this is a case sensitive file system. So all we have to do is just go and change the names to be separate. The easiest way to do this is going to be just to twiddle the names. Introspection. Before I do that, I'm going to actually make the makefile work properly. So click on makefile, FE1, all. So what I'm going to make it do is I'm going to run both the makefile lib and then makefile module. Right. So now if I just type RISC OS ammo here, it'll try to build the library and then that. Right, which means that when I go into here and I use the editor's build system, I can go Command B and it still doesn't work. Well, that's very irritating. I wonder why that is. I know why that is. It's because it's trying to find it in a different place. How weird. How weird. Okay, let's I want to use the build system because I've managed to get this working. Had managed to get this working in the past few days, and I was wanting to try and use it. Let's debug that. Let's just see what we actually got there. If I can remember how it goes. I don't actually remember where these files are. Library, not that. Sublime text, user, packages. Where's my? Let's do it from there. All right. Packages, user, that's why. Right, and I want the RISC OS make system. RISC OS here. Here we go. If it's got a make file, if not, current directory has a make file star, and that does. Let's try that. Let's move that out of the way temporarily and try that instead. Too many arguments. Oh, ooh. Do it bash style instead. But it did give me errors here. I can see error messages, so just rebuild that. All right, that is doing the right thing. Okay. And the reason for doing that is because it then gives me these links that show me exactly where the problems were. So I can do env numbers and force read sys info there, and then build it again. Huh. Now it's not even doing anything. There we go. Now it's done it. Right. So in theory, let's see. I may not need the editor window there. Can you move that up, please? Right, another one in CLI parser. So I'm just jump to that. Env numbers build. Right, module built. Good. So it's now built from clean. So we've made some changes. Apparently I inserted something odd into there. Didn't mean to do that. Oh, that was me trying to understand the MSR tables and trying to do lots of debug. So let's just select the bits we want to do. So hopefully this is readable. It's a little bit smaller, I'm afraid. I don't think I can bump the size up. No, it's not letting me change the size of the text, I'm afraid. But I'll just stage the bits I need. There's a config option for that. Settings, preferences. Ooh, 16 is a little large. 14. I think that's better. Yeah, that looks all right. I'll just move that over here. There we go. Right, so I've just changed that bit. I've just changed that bit. Don't want those bits because those were from my trying to work out what was going on with MSR. All right. So this is commit fix for case sensitive builds on Linux. File names include files for incorrectly. Okay, push that so it's on the live system. Right, so with that I was in the process of testing things. We've got some debug code in there, so I'm going to stash that out the way, and then we'll give it see how it gets on. Load module debugger. We also want shared C library and bits, and drop to command line. There we go. Bum, bum, bum. Thank you very much. Modules. We have debugger. Memory I 8000. Yeah, although I stashed the code, I forgot to actually rebuild it afterwards. So let's just rebuild it. There we go. All right. So now when we run it, we should actually be seeing what we've got in there. Dun, dun. Right, so yes, we can disassemble things, but we can only disassemble certain things, obviously. At the moment, that's a little frustrating. So, I had a test in here somewhere. Oh, sorry, I'm not in Linux, in Viscos anymore. I had a test in here, debugger thumb code. So I think this test code here is the one that actually does the testing of instructions. So let's go back into there and run debugger. Maybe it doesn't. Maybe it needs to take a parameter. Ah, there we go. Disassemble ARM instructions is what we want to try to begin with. Okay, it looks like we need to, some part of it's been rebuilt here, but other parts haven't. Fair enough. So, there's some bits here that are not being recognized as MSRs, which is what it was having problems with, and some bits here that are going a little bit screwy and trying to assign to multiply, which isn't right. So we're going to need to have a look at how this is built to understand what was going on with that. Of course, I didn't leave myself any notes other than the video, and I didn't rewatch my video, so I don't remember what I was doing. So we will have to have a look at it in situ, I suppose. Let's have a see. Right, so the bits we were seeing in here were in the ARM v7. Not recognized. Or was it in the table code? No. I'll just have a look for it. The message was recognized as IMSR. Oh, I'm still in RISC OS. Interesting. Maybe it's because it's recognized as and then it's got a string in there. Okay. Unstash. It was in v7, I'd just hidden the code. There we go. Okay. This is where it's recognized it as IMSR. I seem to remember that it was recognizing it and then it was getting confused later on because it had spotted something else. Which we actually print out. Recognize MSR, branch miscellaneous, and then recognized as IMSR. So it's got to here, got to here. And then it's not doing the later bit here. Not quite sure how that's. So let's try following the code through rather than just hoping I remember what I'm doing. So this bit is populating the different instruction types as it goes through. So it knows that it knows the immediate value. It's got RN, register N. It's identified what the number of that is. Which is fair enough. And then I think it's in the built table code here that we end up getting confused. Because I think things like this that print out spec register, I think those are wrong. I don't think we support that sequence. I think that needs to be replaced with something. I mean, I think that's what's going on. It could be something quite different. But I think that's what's confusing it. Because I'm pretty sure that this parser that handles this only handles certain letters and knows how to handle those. So this code comes from wonderful Python down here, I think. This is the table of instructions. Here we are. This is the table of instructions. Oh, that's not quite it. That's just instruction data. Okay. Where does it come from then? That's the old table. Ah, this one's in there. That's fair enough. General table. Oh, I thought it processed a descriptive file that said something about it. I'm not actually sure now. Right, look in the table code. This is the table code. Oh, I don't know. Let's look in the make file. What builds ARM v7 table? Okay. Oh, they're all generated through this chunk of code here, these chunks of code here. So DARMgen then calls on to all the others. Yeah, so here we are. This is the rules. It says if you see a brace S, turn it into this. Where does it turn it? What does it turn it from to? Because presumably this is reading a file somewhere. Open. Magic open darmtable. Instructions, read lines. Does instructions have more complex things on it? No, it doesn't have anything special in there. Oh, there's this thing. That's just the Ruby interface for it. Don't need to worry about that. So I was looking for opens, wasn't I? Oops, no, I didn't mean that. Go back to where we were, please. Open. Not in there. Not in there. Oh, this is a big table, I think. Okay. Oh, maybe there's a big table in both of them. There we are. So MSR. That one's commented out. Did I comment that out? I don't know. Git let actually. Can I do it in here? Nope. Blame. There we go. No, I didn't do that. So that's not me. It was done a little while back then. Okay, so we don't need that. So it's looking like in both of these cases that we've got some certain limitations. We've got different instruction types that are not being handled. So that's why that one's commented out. It's unlikely that if I uncomment it, it would work, isn't it? Yeah, I think so. Is spec reg used anywhere else? No, it isn't. But it is handled for MRS, or it is available in the MRS. Let's have a look for spec reg in. It's in the table in the MSR, MRS and MSR. That table's got both of them generated in it. That's interesting, isn't it? And in the Python files, star.py. Table and table 2, how are they different? Ooh, they're quite different. Table 2's got more stuff in it than table 1. Because that's got right, okay, so table 2 is for thumb code and table 1 is for ARM code. Right, okay, that makes sense, I guess. Probably. Let's have a see. Do we have any? We've got 6 viewers apparently. Anybody want to say hello? Who's watching me flail around wildly? Right, so this is ARM code. Right, now I've got to grips with that. Let's see what we can do about this. So I've lost the MSR already. MRS, oh, it's also got CoPro stuff in it, all sorts of bits. MSR and MRS. Yeah. Special register, special register. So not quite sure where the special register is mapped to. It says here, this set of things here is where they're being mapped, where the registers are being mapped to, apparently. So, okay. Back to Gen. So this is where we did the replacements for the different types. What's the instruction? S is added to the instruction. Right. So let's have a see if we can introduce this special register. Genuinely have no idea how well this is going to work, but we'll have a see. Special registers used in MSR, RS, MSR. Quote bracket spec reg. Was it spec reg? Yeah, spec reg. And I've got to find a letter that I can use here. How about lowercase s? Oh, lowercase s is there. Lowercase p? Oh, thank you. Got some pineapple juice. Thank you very much.
No worries.
How are you doing?
No worries.
Good.
See you later.
Thank you. Hang on a second. People are also pinging me. Okay. Oh, I've already forgotten what I was doing. Yeah, so I'm looking for a letter. Oh, I can't use P because that's used for OPCs. Can't use C, I don't think. I think I saw a C up there. C is there. Capital C? Yeah, it looks like capital C is free. No, it's not. Copress is there. O. O's already done. Capital D. Just going to pick a random letter now. D's use lowercase there. Right, no other D's, so let's use D. D has no meaning. Let's just and I've misspelled that. Okay, so now I need to make it regenerate the tables. So c dot dot make. Let's do make there. Well, the native version appears to have worked okay. So that's quite good. How do I actually target building a binary? A little disassembler tool test. Is there an assembler tool here? Utils. Elf DOM. Make elf utils. Elf DOM is up to date. Okay then. Oh. Well, that. Oh, I didn't mean that. I meant the C file. Oh, except of course these things won't be ELF, will they? Because they're native files. They'll be Mac-O files. So if I want to do an ELF file, I probably want one of these. Although they won't be. Yeah, they should be okay. No, they're not ELF either, are they? Stupid. I don't know then. Somebody's telling me that we've got errors coming up. Have I set this to be moderated or something? Hello. There's always issues with things like this. Reactions, yes. Moderation activity, no. Timestamp, send feedback, participants. Ah, well, Dave can say hi now, so apparently it's working now. Okay. Not gonna worry. If it's working, it's working. If it's not, then it's YouTube. I don't understand. But we're good. It's also YouTube's also complaining that my bitrate is lower than the recommended bitrate. I think I'm actually maxing out 2.5 megabits. No, I'm not maxing out my connection, but it's okay. Anyway, I am still trying to work out what's going on here. Tests. What we got in tests? Test/tests. Unit test not successful. Huh. Well, that's interesting. Might have to look into that one later. It does have reasonable testing for this then, so yeah, I'm going to have to come back to this. Wonder why that would be. That's sad. Problems downstairs. I'm just going to might have to pop down and have a look at that. Let me see. Okay. Right, well, in which case, let's see what we're getting on. So this might be useful for diagnosing what's going on, but it's not helping me with this particular MSR problem, which I am seeing right now. It's actually quite nice to debugging on this. Ugh. Right. So I've generated this, which means that it'll have generated some table code here. Is it here? For the MSR. MSR. Which has now got a D in it. Which is obviously something. I need to work out where that D is interpreted. Is it in here? No, that's what that's another generated file. Is it in here? Quote D. Let's see if I can find where. No, not in there. How about in here? Ah, this looks like something. No, that's the command line. Oh, maybe that is it. Yeah, this looks like the processor for those things. So, what I'm understanding from this is that it's identified what the next parameter to the operands, next operands should be of type D, which is a special register. And a special register could be CPSR, SPSR, CPSR all, CXSF or whatever, all that sequence of things. But we don't know about them yet. So what we're going to do here is I'm going to add one of these and add an interpreter for it. So it's BDO. There's the CR registers, yeah. I see. Okay. And args. Right, so we're constructing a big array that's got all the strings we want to put together, I think. Pretty sure that's what we're doing. But we need to have decoded which type of register it needs to be. And that decode would have happened somewhere in here. So if I search for MSR, these bits here, yeah, here we go. This bit where we're starting to spot it as these. So we get to set IN, we get to set IM, and we get to set I, but we never set the other register. Whether there is a special. So let's see if we can work out how to populate that. What is D? It's a DOM T. Okay. It's one of these. So this is the decoded instructions. And we should have a spec reg in here, I suppose. D. Oh, is that my new D? That could be a new D, is that correct? Diff. Maybe dom.h isn't actually even in there. I can't imagine that populated it into there because the others would have done as well. I think. Yeah, D is an independent thing. It's used in thumb instructions. So what we'll do is we'll introduce a uint32t called spec. Special register for MSR. Now the thing that's important here is I need to know what the heck that actually is. So let us have a look. ARM encoding MSR. There we go. Oh. So, if I've understood this right, and we go back to the DARM table here, and look for MSR, we should find this looks very, very similar. This is that's the thumb encoding. This is the ARM encoding. So we've got condition 00010R. If I go back to here, 001 0R. That doesn't look right. Interesting. Interesting. Is it saying here? 0001. I can't really. Try and get them both on the screen at once. Whip. There we go, and then this one, move it up a bit. Come on, move. There. So, here's MSR. So you can see we've got 0001 0R 10. It's 0001 001 0 MSR. So that's kind of interesting as well. So does that mean I could assign that to R? Because it does say that that's kind of important if we're doing it here. Oh, pigs in space. It's toggling me to the wrong screen when I click on the things there. That's not very good, is it? Right. I hadn't noticed that. Sorry about that. Yeah, if I click on the Chrome window, it goes and toggles me to a different screen, which isn't very useful. So we're definitely going to need to know that one. I don't know if I can safely use the letter R, because these are going to another register thing. Let's see what happens, I suppose. R in lowercase. I called it R capital. Let's use a capital R, shall we? Just for this one right now, so that's MSR. And we've got not sure how many bits MSR is meant to consume, because it looks like it consumes 4 bits there, and this only says, let's have a look at what MSR actually is, because that's not helping me. Right, move to special register. I'm assuming that is I only take 2 bits. So I'm going to see whether that exists anywhere else. No, it does not. So I'm going to change that to 4 bits, since that's what the specification now says. I'm going to label this one MSRT, MSRS for the I'll call it MSRS. It's worth 1 bit, and this is use this is the SPSR register. Okay, so let's rename this. So this is called the MSRS. This is now 4 bits long, not 2 bits long. There are then 1, 2, 3, 4 ones in brackets. Let's need to move this along. This will cause us to jump screens, I'm afraid. There we go, just scroll that along. That's just my automated switching, I'm sorry. I could turn that off temporarily, couldn't I? Just give me a second. Yeah, there we go, so now everything's fixed. And then everything else is, hang on, I'm looking at the wrong instruction, MSR here. Everything else is zeros up to the RN at the end. Right. So that's that instruction. Now we need to find the other one. Scroll down to there because MSR immediate as well, which has a obviously different encoding. So that's this line here. But it follows the same pattern. We get an MSRS here. I should call it MSRR, but yeah, for now it's good. It's encoding the whether it's the SPSR, and then MSR is again 4 bits, so those 2 go away. And then we've got an immediate 12. Is that correct? It is correct. All right. Now let's have a look at MRS. This one here. Just noticed it says that this is superseded. Go to latest, I suppose. Oh, in which case we won't do that. Why would I like these online things? They're quite useful seeing them online. If mass is, oh gosh, so they've got many overrides on this. Right, anyway, so what we had was this one I'm looking at now, sorry, MSR. No, I've done those 2. I want this one, that's what I'm looking at. There. Right. Oh, hang on, have I got myself confused? MSR immediate. Yes, I've got myself confused. So I want to be looking at MRS. not the thumb encoding. Right. So MRS has 3 zeros, 1, 0, then the thing we're calling MSRS, then zero, zero, 4 ones, RD, four zeros, RD 40, that's no brackets, 4 zeros without brackets, and then 4 zeros at the ends. Okie dokie. So with all that, that's now got as a sort of encoding there that we can use. So we try and build it. Make. Apparently that did something. Okay, so we have a look now in the C5 of the table. Find MSR. MSR has got the CD, and that's got. Okay, so that, yeah, it seems to be doing something. We don't, of course, know what the D is, but where does the MSR part of it get decoded? That immediate that it defines. Let's have a C, shall we? Check for MSR in C. Okay. Hang on, it looks like I've got the R in there. Did I forget to save it? I forgot to save it. Interesting. I expected something to fail because this MSRS hadn't been assigned anywhere, but it hasn't, so I'm a bit confused. Okay, for MSR in and in C, nothing. I don't understand how those get together. This is what you get when you try and just understand things in a very, very vague way. On the plus side, this does seem to actually have some testing on it, so I'll just check that I've actually armable to no.py. Yeah, so if it had failed, it would have not summed up the bits correctly and would have ended up with something that was a bit different. So this is at least correct. This table is now known to be doing the right thing, which is good. At least that's part of what I'm trying to do. But what does it actually mean? I'm assuming it means that we're not actually decoding any of those parts into anything. So we needed something to hold that particular value in there. The demask appears to actually be set here. So we probably need to also set, well, mask. What is mask used for? I don't know. Where? No, can't type. It's using the thumb only. Interesting. Here. I've already forgotten how this works. Is it in this one? It's this one, yeah. And when we hit the MSR, that's an MSR immediate. And it's putting it into RN. And immediate it's setting as being the... Ooh, that looks weird. That looks very strange. Because MSR isn't always an immediate instruction. It could be a non-immediate instruction. Target register. I can confirm this by going back to the MSR here and saying not dumb encoding, this encoding, the ARM encoding here. So yes, target register is in the low registers here, and it's put into this MSR here is put shifted left 18, so just those two, not 16. It should be 16, 111. I'm assuming that's got because it's got an immediate thing in it. But we haven't. There's the mask. Excuse me. So if you even look at the immediate instruction version there. So actually we should have an MSR immediate because there's a MOV immediate. Oh, okay. Type wrench misc instra lookup, and that's in taking it from these here. has them all low. And this has them all low as well. So this is an MSR immediate. Oh no, it doesn't. Oh, hang on. I need to actually look that up, don't I? It doesn't have to be set. Okay, where does that come from? So it's set the ones that's got all zeros here is a register version, and it ends up being MSR. So that's fine. That's a register version. But the immediate version here, which admittedly is a lot more rare. Oh, come on. Hang on, wouldn't have them there, it would have them up elsewhere. That must be coming out as a different type of instruction, because it's not going to go into the branch MISC. This is an MSR register. Immediate, this is the mask. Right by 22. This is the SPSR flag. Okay. And do we actually have an encoding here of what the spec registers, what this encoding is here? Mask equals 100. Yes. There we go, these are the fields we need. In the form. FSXC. Okay. That's fun. Alan says, I'm taking a break from coding to watch a video of someone else is coding. Fair enough, you can watch me coding, or struggling as it may be. I'm in great difficulty trying to follow this. It's quite, the original disassembler is actually quite good because it's just based on the ARM manual, which means that I can actually look across from it and see what's going on, but it's not very well documented, and I'm not doing any better at documenting that, I don't think. But not a big deal. Yeah. Oh, so let's see what we're doing here. So this is what we're trying to decode here. We've got the CPSR flag already been extracted. Did I put it into the DOM header file? Don't believe I did, because I would need to describe it in here. Yeah, special register. So the special register actually goes into IM. for that. And here, let's call this MSRS. It's called the R bit in the documentation. Okay. Confusing. Okay, so if I now go back to here, was that the mask? What is it? Like 16? Yes, that's correct. Okay. So, trying to work out what I'm doing. I've got it to here. I need to get it to the expansion section, which is in D, when it encounters the letter D. It should be, that's this sequence here. Here we are. This is no good, is it? Because if I put it into immediate, then when I have an MSR immediate, it's not going to work. So I'm going to have to put it into MSR mask. So between these two, that's going to give us the right bits, I think, he says. But that also means I've got to add it to the header here. Anyone who says the ARM encoding is logical and obvious may be thinking of things in the old days, I suppose. So there we go. We've now set up the mask and we set up the R, which I called. Should I call it R? Or I should call it R here, shouldn't I? Yes, let's call it the R bit. Otherwise, I'm going to get myself confused. And then we go back to the DARM file. Yeah, and now we've got to construct what that means to the code. So, if you come across a D letter, if MSR, if the R bit has been set, then append CPSR. No, SPSR. Otherwise, append CPSR. And then, and we want an underscore after those as well, because then we're going to put the other registers on. Actually, if D2 MSR mask is not equal to 15, because if it's 15, that means transfer all flags. So you would probably just say CPSR or SPSR. So it's either of those. Append an underscore. I'm assuming that args has a big enough buffer that we can actually do this, but we will see. it'll crash badly if it isn't. Right. So remember from over here, here's our fields. So bit 0 is the C bit. One is the X bit. Bit 2 and bit 3 then are the S and F bits. What could possibly go wrong? Right, make. Where did that end come from? That was clearly garbage. Oh no, actually that's correct. It's not. It was and. There's a bit. I want to check the bits, don't I? There we go. Yeah, that didn't do the. Oh, it's not working properly there. Doesn't matter. Let's just make it here. Got a backtick in there. That's not going to have worked. This looks like I'm appending quite a bit of text. And there's only 6 assigned here. 5 assigned. Yeah, 6 values assigned. 2, 3, 4, 5, 6. Maybe I should just use an array there. Actually, maybe I should just do this as a constant array. Maybe that would be the way to do it. I mean, it'd be tedious, but similar to how the registers are done, I suppose. Is there any other example here of it using a DOM register name? What's that do? Oops, went a bit too far there. Oh, go to definition. So yeah, that just looks it up in the registers. So append args bracket arg comma d that thing d to MSR and d to MSR mask. Yeah, that sounds okay. Right, now I need to find out where this is defined. Oops. Not in here. Not in there. Is it in a header maybe? That'd be a bit odd, but it is in there. It's in DOM tuple. So I'm going to have to, I'm assuming that means I've got to generate it. So if I just search for that in star.py. There it is, in DOM gen. Okay. Hello. Okay. Special registers. And there's not 16, there's 32 of them. Well, that's very simple. Let's define these. So, actually, that's a very good point. So, that would be CPSR none would be the 0 bit, which has no meaning. If you say transfer from no bits of the CPSR into, that means it must be a special instruction somewhere, which is probably what it was meaning by that value being 0 somewhere. Was it in here? Was it in this one? I think it was in this one. That's the SPSR. No. Yeah. I don't know. But it probably means that there's a special meaning. They just try to pack lots of things in, so that's why I'm being nervous of that. G is the same as weird. Well, anyway, we're not going to worry on this. So let's do them in the order that they're set. This is going to be fun. CPSR underscore C, CPSR underscore X, CX. I'm going to do them this way. CS. Oh, mix me quotes. Oh dear. So anybody who actually came along to see like a really good coder, they're being sadly they'll have been missold. Right. This is 8, isn't it? So 8 is 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 is F. FC. FX. Oh, F goes at the end, not at the beginning. Right, all around the wrong way. Maybe it would have been better to programmatically do this one, but doesn't matter. And then finally, that's the same thing, but with S as well. SF. And then finally, CXSF, which is everything. And then it's the same thing, but for the SPSR. So replace only in selection CPSR with SPSR. What should I write? Should I write it explicitly? I'll write it out explicitly. CXSF. Okay. Make srec is not. Oh, because that shouldn't have been rec. It should have been reg. And then we're also going to use the correct. This is the special registers. Okay. Build it. That didn't work. Call to undeclared function. That probably means I use round brackets rather than square brackets. Let's have a look at dom.c line 555. Oh no, that means I didn't declare it. It was in here. Special. This needs to go into a header file somewhere. Huh. Oh, yeah, of course, you have to look for the right thing, otherwise you're not going to find it. That was the one I was looking for. It's in DOM. Now I've declared this one. I don't think those are related to anything I've done. I'm just going to check though. Zero it just as it suggests. Actually, no, it's suggesting it should be initialized at its point of view. Yeah. I'll just assign it to 0 just to make the compiler happy. That's better. Right. I really have no idea if this is going to work. Let's go back into the RISC OS directory. Okay then. Nope, I didn't want to pick the whole thing up. I just wanted to make you bigger. That's better. Right. Debugger. Oh, how do you work? D. So that's not working, that's not working, that's not working. Doesn't look like any of them are working. So, bother. That's somewhat frustrating, to be honest, because I'm sure that we should have done something out of that. Let's make sure we actually did rebuild everything, shall we? Ah, lib, I didn't run the export on. That should have an export there, otherwise it won't actually use it. Is that what's gone wrong? So let's see. Misquoting dire straits. Money for nothing? Don't know. Sorry, Dave. Debugger. D. Whoa, whoa, big bang, big bang. So. Ooh, but look at that. Look, we have registers. I mean, they're not what we wanted, but they're registers. But it does look like when it's triggered, it's doing the wrong thing. So that's a good thing. At least it says in my code. So we've got an MSR R1 there, which is clearly garbage. There. R6 is 0, R2 is big number, that should be okay. R2 has ended up being 1. Maybe I should just do this with tracing enabled. Boot debug trace block, and then we'll be able to see it a bit more clearly what actually was executed at that time. That ain't working. That's the way I do it. That's what Dave was suggesting, misquotes. Darm register sounds like a Game of Thrones character, says Dave. Can't deny that. Right. Be nice if I had this cut down so I had a little bit less of a convoluted way of testing it, but for the moment, this is what we've got. Oh. Right, sorry, there was my broken bits. So, what did we do? So it decoded okay, then we've got a try to read from low memory, byte to C. Interesting. And the last block it was trying to do was try and read from R0. And R0 is 2F. Right, okay. Well, that's why it broke. We're in DARM string. So here's the D. This is where we found the D letter. Then we went and obviously we would go in and try doing our copy thing that we're doing. And it's saying it, how odd. If it's less than 32, then do that. And it returns. So it did return, but R0 came out with a silly number. So that's reading out of the table of the characters that are present. And this is where it tries to read the first character. All of that's done in append. Oh, hang on. Did I forget to do args++? No, args++ is only needed if we do one explicitly. Otherwise, it's just safe. Does look like it's just the copy that's failing. Because that's reading the first character. Hang on. What we can do, that address. Of course, it's running through our debugger, so that's a bit more fun. Hang on, is that not... Did I misread that? Read the address of that, and then from that, do that. Yeah. So the address of that was 012080. So So this is the actual table. Looks okay. How far? What value are we actually looking at? We're looking at R0, what the value was. We don't know what the value was at that point, unfortunately. We haven't got the disassembly. Are there 32 values there? That seems like 32. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then some numbers here. These are the figures I'm looking at. That's a pointer, but that's not a pointer. It makes me feel that it's going wrong. Let's have a look at what that message is. Memory. Can't spell. Did I get the base address wrong? I don't think I did. Oh, I know what I did wrong. I know what I did wrong. Go back to the generator. There's no space at the end. These have all been concatenated. That's why it had some things that came out with long strings in them. Make there as well. Let's try it again. I could probably take out the decoded OK message as well. I think it'll be time for a break shortly. Oh, no, it's still broken. Are we broken in a different way? I hope so. No, we're broken in the same way. What? See, that looks like it's got most of them there. So what would that be then? That would be 4. So that would be 16. So that would be 80 of 32 of them. That is truncated. Am I? Yes, I'm stupid. I reassigned it rather than incorrect. Oh, space on the end there either. Right, and we try again. Debugger D. Oh, I wanted to take that message out, didn't I? Somewhere in here, I think. Or is it in here? Sure it is actually. Not in there. Oh, maybe it's in my side of the code, the RISC OS side. Right, let's jump back to where we are. Oh, look at this. Okay, so we now have some instructions that are actually there. We're missing a comma, but SPSR CF. That doesn't seem right to me, or maybe they are. What should these be looking? Right. So without loading the debugger, so actually this is not bad. So if we have a look at this, like this SPSR CF FC, I think they're back to front because of reasons, but I think they're right. So let me just copy those and put them in a so I can see what I should be expecting. It'd be nice if this actually checked what was output, but the output from each of the disassemblers is going to be different. So I don't actually check them, I just check that they're sensible, as in they decoded. Right, I do want to get rid of the message that printed out decoded OK, because that's getting irritating. And I suspect that's in our module decoder. In here. Coded OK. No. How about the interface library? There we are. For now, we'll just comment it out. Okay, so there we go. Right. Right, so now we're just going to actually see what it was that we're actually decoding. I think in a moment, well, we'll see what happens, and then we'll have a break for 10 minutes or so, because we're nearly up to 2 hours now, and I'm getting a bit tired. I just need a little bit of a break. I'm not going to go longer than 3 hours, though, I think, because... Oh, pigs in space. Stop it. Right, make. Thank you. Now we build it. And try again. Yeah, so we've still got the other output in there, and some of those are wrong. But if we just take a copy of them, we should be able to see which ones we've got and which ones we haven't. Okay, so here's our expected file. Let's have this a bit bigger, shall we? You're not going to let me move you, make you bigger, please. Please. Thank you. Right. So yeah, we've got these additional bits here. So these are constants, immediate values that appear to have come out wrongly. Okay. Start from the top. So this one's ended up looking as a signed multiply. That's just wrong. We'll look into that. But that's MSR, not MRS. MRS, not MSR. This one is correct. We're just missing the comma. We had the comma in there. That'll be the same. So this and this are the same thing. This one, yep, that's the same. Same. This one's gone and shown as the APSR version because that is an alias. I think we saw that in the description. Then we've got some branch execute. So this is the immediate constant version. So there's an immediate constant version we need to have a look at. I'm sure we can work that one out. This one is wrong. It spotted it as a, it thinks it's a register version, so it's getting the wrong value there. And then these are all wrong as well. So the ones that are doing MSR register are coming out correctly. The ones that are doing MSR immediate constants are coming out wrong. That's fine, we can work that one out. Because we've got two parts to that. We've got the decoder and we've got the identifier that goes and identifies what type of instruction it is. And the ones that are doing MRS are just blindly wrong. They're not working at all. So not too bad. I think we're getting somewhere with this. I think we're definitely getting somewhere with it. It's just taking a while. So with that, I'm going to go and take a break. Get myself another drink and things. We'll see how we get on following this. And no, hang on, I'm going to commit it first. So let's just commit this. This is not working. So let's have a fixing MSR. Partial fix for MSR/MRS instructions. This change introduces MSR with a register as okay. Push that in. Right, there we are. Right, let's have a break. I'll be back in about 10 minutes or so. Fingers crossed. We'll be able to get a bit further after that. So let's see if back soon works. Back soon. Okay. See you in a bit. Hello, I'm back. Got myself a cup of tea, had a short break. So, let's have a see where we're up to. We have partially working. We're just missing this comma. So let's try and get the comma in, and then I can feel good about those bits. It's going to be a pain, but we're going to have to work out how to do the MRSs. But let's see if we can get the comma in and then the immediate constants sorted, because the immediate constants are going to be the other side of it. Is going to be a bit of a pain. So, where were we? So this is where we're up to. We want to put the commas into here. So inserting the commas. I'm not sure where it's meant to happen, but it'll be somewhere in DARM itself, I'm assuming. Because here's where we've got the D's. There must be something in here that inserts commas. Oh, there you go. So yeah, it says if we've got building some of these into some of the expansions, it looks like. It's not implicit that the comma immediately follows things. Oh, that's helpful. Okay, I'll worry about that in the future. Alright. Is there another D? There is another D. Actually, maybe I shouldn't have used D as the letter to do this. Hang on a second. Oh, I thought something was generating a odd noise. So there's no G's in here, so I could actually use this to mean G in the uppercase meaning left side, and G in the lowercase meaning right side. Is that what they actually do in here? So because the RM is always the right hand side one. Then they've got RNs here that are right hand side as well, which is interesting. Well, what would that be then? So how would that EOR instruction be encoded in the table? I'd have to look in here for EOR, exclusive OR instruction. Oops, gone a bit far. I just want to find the sequence. There we go. Oh, that's an exciting set of letters. S, C, D, and M, S, and S, C, D, N, I. It's quite exciting, really, isn't it? Where are we back in here? So S is the S character, C is the condition, D is the register name, and then N, and then M. Oh, okay, that makes sense. It's interesting though that there's commas between them. I don't know when comma is implicitly inserted and when it's explicitly inserted. the CDNN. So between every one of the arguments, you get a comma. Apparently, that's basically what it's saying. I think. Isn't it? For all of the arguments from 1 to 6, if it's not equal to the... Not sure what that means. Add a comma and then append instra. Oh! Oh! There we go. That's what does it. It's saying increment the... This isn't actually an argument now. Append is just append to the string. So, can I just turn off these recognize? Where was it? I thought it was in there. It's definitely not in there. Ah, there we go. Did that temporarily. Oh, hang on, no, because that was actually giving me the... I've recognized it as a instruction as well. It's literally just the... that bit I want to do. Okay. Oh, we've still got Alan here. Hi, Alan. Hopefully this is interesting, even if it is largely just flailing around and trying to work out how to change this code. As I say, it's quite nice that it's using a table to process things, because it does also mean that if I wanted to, I could probably use this to decode ARC64. I'm not sure that I would, because it's a complex table-driven solution, but it's actually quite nice in that regard. Right. Debugger D. So we're still getting one of the debugs, but we've got our commas turning up now, which is good. So next thing to do is to recognize, actually no, next thing to do is to go and merge that, since the commas are now working. Just comment that one out as well. So it is actually nice. Fix for commas in MSR. not the instruction, the argument. There we go. Right, so that's now sorted. We now need to identify MSR immediate. Now, MSR immediate is the same thing, but with a different encoding. Let's find MSR. So we've got MSR there and MSR. That's the immediate one, and that's the not immediate one. They look very similar, but it's being identified as, what was it, an S-mul? Signed, multiply and add. Signed, multiply and add long. Using the PC, I mean, that would be insane, wouldn't it? As instructions go, that would be nuts. So clearly that's not the way that you would identify an S-mul. Let's just scroll down to find it. Interesting. So which one was it? SMLA BB. Yeah, it's this one, isn't it? I think, and this one here. Let's just start out with this one though. So I just copy this up to where this register is. Just remember to delete it. Those don't look even slightly similar. We've got 0011, this is 0001. 10 there, that should not be matching in the slightest. Oh, hang on, no, this is MRS, not MSR, sorry. I'm reading the wrong thing, aren't I? That's why. All right, let's have a look at this MRS. I said I would go and look at the immediate constant, but since I'm doing this now, let's look here. So yes, these are looking similar. We've got 0001, 0001. The MRS is not set, so fair enough. Sorry, 0010. That's the S bit there. Then 0, then 1, 2, 3, 4. S bit 0, 0. So yeah, it's because RD is 1111. That's why, which is PC, and that's what's telling it it's wrong. So I need to cause it to omit that when it's using that other context, which I don't know how to do that. I don't know how this table is passed. Because clearly it must be somehow. There'll be some bits that are used to identify things. I like this one, darntable. No, that's literally just the mnemonics and strings and the like. Do you generate anything in internal? Ah, that's how it handles binary sequences. Cute. Not what I expected, but cute nonetheless. Maybe it's not using any of these values at all to do the determination, because it doesn't seem to have generated any other table values in here, just the arguments decoder. Okay then. So that being the case, checking nobody said anything. Presumably all the decoding is actually in here. It says here, can't work out how these tables work. Disassemble conditionals. No, what's all of this? This is unconditionals. Boom, boom, boom. So all of these are based on instruction type, which is extracted from the 20th bit and FF. th bit and FF. So that is, hang on a second. So 20 through to 27. So that's all these here, which is fine for the MSR, but for the MRS, it'll clash. Because bits 20, this lot, all match up. These 16 here also. Hang on, is this? What's? Oh, I've lost where I was up to there. Because this is magic, isn't it? F20 dB. Bin dB. I'm going to move the other thing over here, and we'll turn on automatic switching again, because I'm not trying to view them both at the same time anymore. So I can do that. That'll make things easier. So we're looking at bits 20, and it's 110. So 110. That's not ignored. And then what was the things? 11011. Ah, but this is for MSR. Bits 20, sorry, bits 20. Immediate. Yeah, so immediate toggles that one. But all this along here ends up with these bits set. Sorry, not these bits here. These bits here set. If they're all set as well, where is MRS otherwise handled? It isn't handled anywhere. Okay, let's have a go at that. May as well just directly call debugger D rather than going straight into the GOS. I can save myself a little bit of time. Just check, so that's 0, 0. Oh, hang on, MRS is 0, 0. Whereas MSR 0, 1. So that should have been, of course, 20 there for MRS. So I still have that wrong. It has 1 as MRS. Oh, it got confused because it put it in both categories. Yeah, fine. Make and there we go. See, as things go, this is pretty unexciting, but we are getting somewhere, which is at least something. Right. Well, we were. I thought it says that these are MSRs, not MRSs, so I'm a bit frustrated there. So let's try and check this, shall we? Oops, can't spell. 0, 0, 0, 1, 0, 0, 0, 0. Oh, sorry, 0, B. That is the sequence for MRS, which is 16, which is 16. And W should be left 16. This bit here should be 1111. So that should have been recognized. In fact, I want to be clear on that. That's actually E, not D. So it's only bit 1 that. No, sorry, F. I want to check all of the bits on that. Yeah, and that equals that. So I should have recognised those ones. Oh, I'm looking at the wrong ones again. I should be looking at these ones as MRSs. Here we are. Yes. Sigh. It helps if you actually read the right bit of code. So yes, these are MRSs. Good. So now when we're inside the branch MISC, it probably shouldn't even be in the branch MISC. In fact, it probably ought not to be in there at all. T-arm. Interesting. There isn't an MRS type in here. There's an instruction, but there's no type. How does type get generated? MRS has been added on the end here. That wasn't me, was it? Ah, but it has got the R in there. Maybe I should have used that then. Doesn't matter, let's just take it out for now, put it back to where it was. There we go, just leave it like that. Right, T underscore MSR. So that's the thumb table. T underscore MSR. Inch. Yes. So it looks like these are explicitly being handled by the generator here. So I need to find out what pattern this fits into that most closely matches. I mean, I could just put it into branch MISC as well. I'm not sure why it's in branch MISC. I'm assuming it's because it's got a differentiator that is these here. which is true. Actually, it's gone to 0, which is an MSR instruction, which is why it's gone to the MSR here. But the difference between those is the bit 21, is it? Yeah, bit 21. So if I MSR back to if W shifted left if D oh dear, I cannot type. Instra is IMSR and bit 21 is right. So we've now decided whether it's an MSR instruction, which might be an MRS. If not, D to instra equals IMRS. Okay. A little bit of debug updated. So MSR mask is the same, and the R bit is also the same, but instead we've got an immediate here. And the immediate is, this isn't, oh, it's not an immediate, sorry, I'm lying. We've got a RD here. RD, register for the destination, which is in bits 12. Is that it? Is that it? I do not know. Make no, that was not good. Warning, 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 warning. One serious error. I missed it then. Serious error. Duplicated case constant. 76. Yeah, that's why. Can't give it a whirl. Oh. Somebody's asked, soon AI will code in assembly. I don't know whether the assembly is going to be particularly good from AI code. A whole bunch of people on the ARM-related RISC OS forums have been talking about it and have said that it's not ideal. But that's about converting from code from place to place. Realistically, nobody should be writing assembler these days. The only reason to be using it in here is because sometimes you have to understand what things have gone wrong at another level, and try and work out what the compiler's generated that's gone wrong. that's the idea anyway. This hasn't worked. It's gone. Oh, yes, it has. Yes, I'm looking at this one here. MRS, CPSR, CXSF, and CPSR there. We are good. So that has now fixed the MRS part. So let's quickly just turn off those recognition messages. Oh no, recognition messages are down here, aren't they? Yeah, these ones. Right, make again, and then we'll commit it. One of the big problems with coding and assembly in general is the fact that there's a lot of bad examples, and a lot of the examples you'll end up with are examples of things that have been generated by compilers anyway. So they won't be doing things particularly cleverly or special. That's really the crux of that, I think. What have I done? Implemented MRS instruction. Still no handling for MRS immediate. I mean, MRS immediate is pretty rare anyway. It's a odd thing to do, except as a like system level coding example. So the difference in the MRS is in here, isn't it? I've lost it. I've lost it. There it is. So if it's an MSR, we need to know whether it's immediate or not. And the immediate difference is in one of these bits. It's in bit 25? Yeah, bit 25. I'm just trying to think. No, if word and immediate. So this is when it's register based. I don't know what that I means. And left it alone. Oh, hang on, is I set meaning interrupt? Don't know. Not sure about that. However, I've put this in the wrong place, haven't I? Should be up here. Yeah. Let's put this back to how it was. I'm going to take off that I set and see if we get anything different. I'm not completely sure that I understand it. Now the immediate is actually a magic immediate because it's one of these IM12s. Sorry, wrong instruction. It's an IM12, which is special, which is used by this. There we go. Oh. I actually assign it first. And they assign it like this. Okay, no idea if that's going to do anything good. Off we go. If I was sensible about this, I'd have all my code running just natively rather than running it through RISC OS, but I've pursued this the wrong way, I suppose. Right, here we are. I've got that round the wrong way, haven't I? Let me just copy that lot and put it into my expected again. Yeah, all the ones that should be constants have ended up as registers, and all the ones that should be registers have ended up as constants. Well, that was dumb. So if it should be that way round. Because this second part is the immediate. Well, fine. I'd also like to say it's very hot today, so that may have affected my coding ability. Yeah, right. So on the plus side, I now understand a lot more about how the table works in here. So we can see a bit more about what we can do with the instructions. Right. There we are. Now let's pick, oh, this is looking better. This is looking a bit better. And we've still got some that are not recognized, but the bulk of them are now coming out. Okay, so 400 BX, yeah, that's wrong. C, another BX. So those are not coming out right, but I'm not sure why. So we just need to work out what the special condition is that is triggering to send it over to BX, the branch extended instruction. So here's a branch extended instruction. And if we have a look at those ones, what's common about them? Just using the C flag as the destination. And that one. So this only had the F flag set. That's the same as CPSR F. You can see it's there. But when the C flag is set on its own to 0, all's good. When it's not, maybe it's a this is not 0 thing. Okay, so let's have a quick look at my conditional we use here to select whether it's an MSR or not. So $20 and DB. Shouldn't that be FB there? No, because I'm filtering out both that and the other one. That's an MSR. So that's immediate or not. Ooh. And then when we go in here, we're just checking for that bit, if it's not MSR. But a BX, what does a BX look like? If the instructions are BX, hang on. Oh, these are system instructions, that's why. Where's BX? Can't see BX in there. Unconditional instructions. Here we go. Yeah, I thought that was in there. BX is there. There we are. I don't know where that was in the searches. Instruction details, of course. So what it's saying here is that all bits 8 through to 19 must be set for it to be a BX. And for it to be the other one, system level architecture, system instructions, alphabetical list. Open a new tab. There we go. So it's saying that 8 through to 19 must be set. Oops, no, wrong one. And 4 through to 7 must be clear. This is very strange, isn't it? Does that mean that mask can't be 0? Mask can't be everything. And having... How do I decode that? I'm sorry, I'm getting confused here. Because it looks to me like this is quite a... They coincide with one another. You could have an immediate value that has all those 3 bits set. 4 bits set, sorry. And has CPSR CXSF. And it would look exactly the same as a branch extended instruction. Wouldn't it? Oh, bit 25 must be set. If bit 25 is set, it cannot be a branch extended. Which we filtered it into this pool because of what we did earlier on. Yes, it's my fault that I filtered it into this pool, which I shouldn't have done, but maybe I should have moved them out to a different thing. MSR, sorry. Okay. Ugh. Come on, you can do it. And we have a look at this. Oh, this is not looking right either. Oh, maybe it is. Actually, maybe this is right. This is my new encoding, or decoding rather. Yes, that is APSR, that is CPSR, SPSR. I wonder if we should just trim that off, because in the Unicode decoding it doesn't do that. CF, FC, CF, CFSX, C. So I could just encode them as those strings. It's not difficult to change that. 19 is 16 plus 3. 16 is 16 there. Yeah, that looks good. That's all right. Hey! Well, that was painful. So, now what we'll do is we'll just quickly check that we're not getting stupidity. So this is Debugger D, this is new. This is DARM output. Output DARM there. Come on, run faster. And this is output from Capstone. Well, Pyro specifically, because Pyro manipulates the instructions. Right, let's compare the two. Output Pyro against output DARM. So, blue highlighting means minor differences. Red means actual differences, and it'll highlight what the numbers are. So, yeah, they're looking okay. That looks okay. There's just the decoding that comes out slightly differently here. There's a shift oddity there. It's not terrible. It's showing us the right values anyway. And Pyro is being the weird one there. RRX number 0, that is an odd one, but we could fix that up later, I think. RRX is the encoding of rotate right by 0 bits. It is just RRX. Yep, same value. Again, just a slight difference on the OSL, and we've identified it's a table dispatch. That's the same number, I presume. Could do with a decoding of what that offset is. Then same. CS and CC are the same as higher than same or lower. Same conditional again. Those have come out okay. Again, slight difference in the decoding of the values. This one, yeah, the numbers have come out differently. Do I want to make it use the standard naming? I mean, realistically, I think it would make more sense to use APSR and SPSR. APSR, SPR bare, and maybe CPSR bare as well. Actually, CPSR isn't being done bare there. It's being done as the full thing. Interesting. And that's APSR F, which comes out as just APSR intermediary. Yeah, it's ranging them there, which is quite nice. I should do the ranging myself, but I haven't got around to it. And again, RX of number 0. So I think that's instruction barrier. I don't know what that is actually. But I think that's looking pretty good. Do I want to change it to APSR? I'm going to leave them as they are. I think they're readable. They're just not quite the same. So I'm going to be happy with that. Right. So with that, this output is now correct. What have we got in here? Have we got any printfs? Commented out? No, nothing else. All right. Commit -a. Fix for MSR immediate. MSR immediates now come out, are now decoded as a proper immediate value without confusing with BX. Okay, that is a lot. Push that, and then we want to go and check out master, and we can merge it. Merge NoFF. What was it called? I've forgotten already. Fixing MSR MRS. There we go. And I think because that's actually now fixed something, I'm going to remanage ink it as well, so we get a different version number. It was 0.06, wasn't it? Now 0.06. Okay. So disassembly operands are not very friendly. Compare output using permanent debugger tests. So this here says we compare these. Yep, that is now done. So let's. I'm not signed in. Why am I not signed in? Continue with passkey, please. Touch ID. Thank you very much. So that's now done. I can move that over to here. The other thing is disassembly operands are not very friendly. Yeah, that I think we fixed those. All of those branches are now looking okay. If we have a look back up here, we've got the addresses coming out correctly here. So I can say that that's done, I think. Sign myself as well. And I've done that. Okay. So we've got a number of different things here still to do. Error base would be a good one. This is tidying things up. Again, enhancement for in advance of RISC OS 5's version, but it's parity with the Pyromaniac version. And same goes for the 64 disassembly. This is supposed to be a bug though. I think that's quite easy to do though. Right, so we might look at that next week when I come back to things. Okay, so what I usually do at the end is I summarize where we're up to. So we now have a disassembler which provides us with the functionality that we've got in the standard debugger module. Maybe not all the warnings and all the rest of that, but it does disassemble the code as we would expect, pretty much. And we've got code that is pretty functional. I don't think we've got too much in the way of problems with this. One thing I am going to do though, so this debugger module is now working, so let's just quickly make sure it's been built cleanly. Build everything cleanly. And then we can export it. Dum, dum, dum. Thank you very much, built. So if we move this from here to there, yeah, that's fine. So this is my 64-bit status project. So let's quickly move over there. We can see that diff status where's my 32-bit module gone? It's not in there. Go back. Oh, that's because I did an LS rather than a CD. I am stupid. CD to there. And then we can see, yes, there we are, status, git add rm32 debugger. And if we just have a look at that, I'll put it into the editor, it'll be easier. Here we go, right. README file. So if you haven't had a look at this, this is the status of the 64-bit things that I've been doing, which marks all the different modules and what I've been doing with them, or other people have been doing, because obviously other people are doing stuff as well. So we look for debugger. Yeah, debugger is in progress. Let's just put a mark on that. Oops. So this is debugger buffer. Yeah, that was not the letters I wanted to type. Debugger. It doesn't build 64-bit yet. We'll probably look at 64-bit builds of the debugger module. Maybe next week I may have to do some things for that to make that work. So let's just put this in here. Debugger. Debugger works, but does not have a 64-bit build yet. Okay, there we go. Do I want to declare it's working? No, error base may be wrong. We'll come back to that and check where we're up to with that. All right, so that's that. Oops, didn't mean to do that. Save that. Close the window. Yeah, commit. Yeah, commit as a state of the debugger module. Okay, so, and push it as well. If we then have a look at the that module, that command, whatever it's called, repository, that's the word. RISC OS 64 status. Here we are, where you can see debugger in progress, and it's got a link to there. You can see we've got that, and the module is sitting in there alongside the other modules that have been made work. Right, so with that I am done. I will go and put a brief note out to everyone on the rule forums, and hopefully we'll have a sort of catch up next week and see where we're up to. I think the debugger module is pretty much done. I mean, to the point where it's working anyway. We might need to do a bit more on some of the extra things for Pyromaniac compatibility, but I'm happy with it. So at that stage, I think I'm going to move on from the debugger. I'm going to look at doing something else. I'm not sure what yet. I mean, it might be things that are broken about debugger. If there are, then please raise a bug in the issues. I am going to, have a see what I'm going to do next time. If anybody has any suggestions for things that I could have a go at, please let me know. I'll obviously want to take things that are interesting. If it's boring, then I might do it if it's showing off something. But in the meantime, we'll have to work out what the next session is going to be, I think. It may be we do a bit more on debugger. It may be we look at something different. All right. Have a good afternoon. I know it's very hot today, so try and keep yourself cool. And see you all later. Any questions to the usual place? Gerph@gerph.org. And have a good afternoon. Bye. Bye. What do we do now? This is where I get confused because I forget what I need to do at the end. Go to the title slide. There we go. Say goodbye.